Hey guys, welcome to another A Level Maths revision video. In this video today we're going to take a look at circles, kind of look at the kind of core ideas behind it, so being able to find the equation of a circle, finding the equation of a tangent for example, being able to find like the radius and put it into the correct general form. So let's take a look at these questions here. We've got a mix of 5 questions from old exam papers. So the first question here, quite a nice standard question just to get us started. We've got the circle C, which has the centre minus 1, 7. So, minus 1, 7 is the centre. We know it passes through the point 0, 0, so the origin. So all we want to do is just find the equation for C. So, we've already got the centre, so straight away we can start putting down the general form. So our form here for the equation, so remember it's x plus a all squared plus y plus b all squared, where your a and your b are dependent on the coordinates of the centre. So with it being minus 1, this here will be x plus 1 all squared. So essentially you just put the opposite in. So if it's the centre is minus 1, 7, that's going to be x plus 1. So it's the opposite of the x coordinate. And again, it's going to be plus y, with this being positive 7, y minus 7 all squared. Okay. Remember, this general form is equal to the radius squared. So all I need to do is work out the distance between the centre, minus 1, 7, and the point 0, 0, because that would give us the radius. So essentially we've got a point on the circumference, we've got the centre, so if we work out the length there, we've got the radius, and all we've got to do then is square it. So the distance then, well, that's just simply going to be the square root of, I'm going to do it as 0 minus 1. So it's 0 minus, it's 0 minus minus 1, so it's going to be 0 plus 1 all squared. Do the same with the y coordinate, so it's 0 minus 7 all squared. Like so. So that's going to be 1 squared plus 7 squared here. So 1 squared plus, I mean it's technically minus 7 squared, but it won't matter either way because if you square a negative you get a positive. So it's going to be 1 plus 49, so that's the square root of 50. So in other words, the radius here is equal to the square root of 50. Now I wouldn't bother simplifying this square root. And the reason for that is because we write this in the form r squared. So r squared in this case would just be root 50 squared. So r squared is just going to be 50. So in that case, the equation for C is going to be x plus 1 all squared plus y minus 7 all squared is equal to 50 there. Okay, so a nice easy standard question to just get us started. Hopefully there's no issues there. Now if we take a look at the next question, a little bit more work involved with it, and part C just got a little bit of thinking to do with it, but again, hopefully nothing too tricky. So part A then, we want to find the coordinates of the centre of C. So parts A and B kind of go together in one essentially question, and the reason for that is the way to find the coordinates of the centre here and the radius is by getting this in the general form of a circle. So the way I do this is I group the x and the y's together. So in that case it's going to be x squared plus 4x plus y squared minus 2y. We've got this minus 11 here, so I'm going to take that onto the other side, so that becomes positive 11. And then what you do is you split the x squared plus 4x up here by completing the square, and do the same here. So think of these as two different things for now. So complete the square here. So that would just simply be x plus 2 all squared. We take the negative square here of 2, so that would be minus 4. Do the same here now with this part. That's going to be plus y, so that would be half of this, that would be minus 1. Square all of this, and then take the negative square here, so again, that would be minus 1. So that's all equal to 11. So the only thing left to do here now is deal with this minus 4 and this minus 1. So minus 4 minus 1 would be minus 5. But remember, we want the general form to be x plus 2 all squared plus y minus 1 all squared, being equal to r squared. So in that case, I just need to add 5 to both sides. So in that case, it's going to be x plus 2 all squared plus y minus 1 all squared is equal to 16. So now all you've got to do is pick out the coordinates of the centre and what the radius is. So we're doing this in one part then, essentially. So the centre, C, well, we get that from this part here and this part here. So my x coordinate here will be the opposite of the +2, so that'll be -2. Same again here with the y, the opposite of -1 will just be the positive one there. Okay, so my centre is -2, 1. The radius then, if we do it just underneath for part B, well, that's just simply the square root of this. Remember, this is r squared, so the radius isn't 16, it's the square root of 16. So r is equal to the square root of 16, which is 4 there. Okay, so my radius of C is just simply 4. And then for part C, a little bit more thinking to do with this one. Let's draw a bit of a sketch just to kind of see what we're actually looking for. So we're looking for the coordinates of the point where C crosses the y-axis, giving your answer simplified surds. So if we draw a little quick sketch to kind of see what's going on. Again, mine's just a rough sketch, but just so you can see what's going on here. So what's our centre? So we've just worked out the centre as being -2, 1. So in that case, the centre will be roughly, say, there, right? -2, 1. So I'm just drawing a rough sketch. It's not perfect, but just so we can see what's going on. Okay, that's definitely not the centre there. Let's get rid of that and put it a bit close. What would actually be the centre? Let's say that's -2, 1 there. Again, it's not perfect, but just so you get the idea. So that's C, the centre. Now, what we're looking for here is where it crosses the y-axis. So, if you notice, that's this point here and this point here. So, we need to try and figure out how do we actually work out the coordinates at that point. Well, this point here, these 2 points occur when x is equal to 0. Remember, the y-intercept is essentially just when x is equal to 0. So, crosses the y-axis, when x equals 0 there. So all I need to do then is take my equation for my circle and basically just plug in the fact that x is equal to 0. So using that then, we obtain the equation as being x plus 2 all squared plus y minus 1 all squared being equal to 16. Now I plug x equals 0 into here, I get 2 squared, so I get 4 plus y minus 1 all squared being equal to 16. Okay, if I subtract 4 off both sides now then, I get y minus 1 all squared being equal to 12. And it's at this stage here now we need to start solving this. It's up to you, you can expand this and solve using the quadratic formula. The other way you can think about it is this would be completed square form. So if I take the square root here of both sides, what would that give us? Well, it just give us y minus 1 on the left hand side. The right hand side will be the plus or minus the square root of 12. And then to get y, we just simply add 1 to both sides. So in that case, y will be equal to 1 plus or minus the square root of 12. But be very, very careful. We want simplified surds here, so we've just got to deal with this root 12. So root 12, we can write that as root 4, root 3. So root 12, just do it up here just so it's clear. That's root 4 times root 3. And we can simplify root 4 to be 2 root 3. So my actual final answer then in that case is y equals 1 plus or minus 2 root 3. Okay. So that's our simplified surds there. Okay, so it'd be 0, 1 plus 2 root 3, and it'll be 0, 1 minus 2 root 3 there. Okay, so 4 marks for that. Not too bad. Just be aware of the fact that it's going to cross the y-axis when x equals 0. So that's that question done. Let's take a look at the next one. So the next question now here, again, it's not too tricky. There's a bit more kind of a problem-solving aspect to it, though. So, question 12. So it's taken from one of the international papers, by the way. You can find these online pretty easily. We want to find the equation for C in terms of A. So it's slightly different. This time, instead of it being, we're working with a numerical set that we know the value of, here we're just giving it as A being a positive constant. So, in that case then, with this being A0, so the centre, is A0. Using our general form again for a circle, this will be x minus a all squared. It would be y minus 0 all squared, so that'd just be plus y squared. Don't have to do anything extra with that. And then we need to figure out what the radius squared is. So the radius, don't forget, if we just change colour, that would be from this point here, for example, to here. So with this being from the origin to A, that distance is simply just going to be A. So the radius, R, is equal to A. So the radius squared will be A squared then. So my radius is A squared. Okay. So that's just our equation for C in terms of A. And then for part B, we're given the point P, 4 minus 3, and we're told it lies on C. So, for example, that's going to be somewhere kind of over here. So let's just say, I don't know, 4 minus 3 might be there. So we're told that lies on C. Okay. So if we use that the fact that P lies on C, we've got our equation for C here. All we need to do is just substitute in. So this is going to be 4 minus A, because x is 4. So using 4 minus 3. So that's going to be 4 minus A all squared plus y squared, where y is minus 3, is equal to A squared, which we don't know just yet. So if I expand this, this will be positive 9. So this is going to be 4 minus A all squared, so that'll be 16. I'll get an A squared plus A squared. I'll get minus AA there. We've got plus 9 here. It's all equal to A squared. So if I start simplifying here, the first thing I can get rid of is an A squared off both sides. They'll just cancel. So I've got 16 plus 9 minus AA, so that's 25 minus AA is equal to 0. And if we just solve for A here, we've just got a nice linear equation. We get AA is equal to 25. So in that case, A is equal to 25 over 8 then. And there we have it. So 3 marks for that. That's quite a nice one, I think, overall. Now the next question here, I really like the last question, part C. It's quite a good question to look at. A and B, pretty standard again. So we want to find the coordinates for the centre of C1. So C1 is the one that we've got the sketch of here in figure 5. So we've got the points A and B, which lie on C1. We're told A to B is a diameter of the circle C1. So if we find the midpoint of that diameter, we know the coordinates then of the midpoint. In other words, the centre of the circle. So let's just kind of jot these points down. So if we say A is, I don't know, 1, 4 here, right? I might be a little bit off, but let's just say that's 1, 4. If we say B is 7, 8, so that might be, say, here. Again, I could be a little bit off, but just we've got a rough sketch. What we're looking for then, if this is the diameter, we know the midpoint is, say, roughly there. Okay, so all we need to do is work out the midpoint here. So AB midpoint, well, that'll just simply be the average of the 2 points. So that's going to be 1 plus 7. So the x coordinates added together and divide them by 2. Do the same for the y coordinates, so 4 plus 8 and divided by 2. So that'll give us 1 plus 7 is 8, divide that by 2, so we get 4. And then 4 plus 8 is 12, divided by 2, we get 6 there. So what we know then is that the midpoint here is 4, 6. Okay, so 4, 6 there for my midpoint. For part B, we want to find the exact radius of C1, simplifying our answer. So to do that, all we need to do is work out the distance from, say, here, 4, 6 to 1, 4. Okay, that'll just be simply the radius there. So if we have a go at that, part B then. So working out the distance from 4, 6, let's just write it down just so we've got it on the screen. Working out the distance from 4, 6 to 1, 4. Okay, so this will be the square root of 6 minus 4 all squared plus 4 minus 1 all squared. And if we work this out, so that's going to give us 2 here. So that's the square root of 2 squared plus 3 squared. That's going to be the square root of 4 plus 9. It's going to be equal to the square root of 13 there. Okay, and that's simply our radius there. So again, let's just keep jotting this down because we're going to need all of this for our part C. So from here to here, my radius, that's root 13. Same again here, we've got another root 13. So in total, my diameter is 2 root 13. And now for part C, it really does take a bit of thought on how to solve this one. We've got 2 distinct circles, C2 and C3. Both, again, have the centre here, 0, 0. So, we're told that each of the circles touches C1. So, in that case, if both of the circles touch this circle C1 here, and they've got a centre at 0, 0, we need to kind of figure out what's actually going on. Well, in that case, what I've actually got is I've got these 2 circles, and one of them is going to touch just here, like that, and that circle would keep going round. Again, centre 0, 0. And I would also have this circle right at the top here, and again, my artwork's terrible, but as long as you understand what's going on. We've got this other circle here right at the top, and it just touches C1 like that. And again, that circle's going to go all the way around with centre 0, 0. So, in that case, we need to work out the equation of the circle for C2 and C3. Now, with them both having centre 0, 0, hopefully it jumps out immediately that they'll both start as x squared plus y squared. Okay, so as the centre is 0, 0 for both of them will be x squared plus y squared. It's just simply equal to r squared then. Okay, so the question is, for C2 and C3, what's the radius for each one? Now let's consider C3 first. So if I denote this one here as C2 and this one here as C3. C3, in fact, we'll have to work out C2 first. The reason for that is because for the radius of C3, we're going to need this full length here. Okay, that would be my radius. If that's my centre, a point on the circumference here would be the radius. So to do that first, I need to work out this length here from the centre to this point on the circumference here for C2. Okay, obviously that should be a straight line, but my artwork's terrible. So we need to work out what this length is here. Now the easiest way to do that is to consider this whole length here from 4, 6 to the origin, and then subtract the root 13 off. Okay, because we know this length from here to here is root 13. So if we work out the full length and subtract root 13 off, we've got the length here for this radius. So if we work that out, so calculating the length, or calculating the radius for C2, so like we just said, what we're going to do is we're going to work out the full distance from 4, 6 to 0, 0. So that's going to be 4 squared plus 6 squared, because obviously 4 minus 0 plus 6 minus 0 would just be 4 squared plus 6 squared. So what would that give us? That's going to give us 16 plus 36. So that's equal to the square root of 52. Okay. So what we've just said is that if we work out the full length from the origin to the point 46, and we subtract root 13 off, what that then leaves us with is this length here. Okay. Because we know this length here is root 13. So in that case, we're now doing root 52 minus root 13. So at this stage, how would I actually do this? Well, we can use the fact that 52 is a multiple of 13. Okay, we can write this as root 4 root 13. So that would be 2 root 13. We're just going to minus the root 13 off. And I can write this as 2 root 13 minus root 13 to just give us root 13. Okay, so this length here is also root 13. So what I've got now is root 13 from the origin to this point here, root 13 from here to here, and finally root 13 from here to here. So now the final question is, we just need to work out this radius here. Because once we've got that, the question's done. Well, that would just be 3 lots of root 13, right? Root 13 from here to here, here to here, and then here to here. So what we've actually got now is both of the radiuses. So in that case, we can write down both of our equations here. So if we do it in a black pen, for C2 then, the equation would just simply be x squared plus y squared is equal, so it'll be equal to the radius squared. So my radius is root 13. It's going to be equal to root 13 squared. In that case, we get x squared plus y squared is equal to 13. So that's C2 there. And then finally for C3, same idea again. It's going to be x squared plus y squared is equal to 3 lots of root 13 squared. So that's going to be equal to x squared plus y squared. It's going to be equal to 9 times 13. So that'll simply be x squared plus y squared is equal to 117 there. Okay, and that's both our equations for C2 and the equation of circle C3. So quite a good question. I do like that question to finish with. For that question, bit of a problem solving, gets you thinking a bit, but yeah, so that's the end of that question there. And then we look at this very last question here, just a nice standard one to finish with. So I picked this one because it involves finding the equation of the tangent, which does come up quite a bit, so you need to know how to do it basically, but it's nothing too crazy. For part A, we've just got to find the equation of the circle C. So very standard. I think it was pretty much the first one we did in this video. All I'm going to do is work out the distance between 2 minus 1 and 4 minus 5, because that's my radius. So calculating the radius. So calculating R, so that's going to be 4 minus 2 all squared plus minus 5. So it's minus 1, so that'll be plus 1 there, all squared. So what would that give us? Well, that's going to give us 2 squared there. And this would give us plus minus 4 all squared. That's going to be 4 plus 16, so we get root 20. But I'm not going to bother simplifying this, again, because we're looking for the equation of the circle. We use r squared. So in that case, r squared will be root 20 squared, which will just be 20. So now we can write down the equation for the circle C, which would just be x. If the centre is the point 2 minus 1, that would be x minus 2 all squared plus y plus 1 all squared. It's equal to r squared, which is 20. Okay, and that's our equation for the circle C. So that was part A. Part B then, we want to find an equation of the tangent to the circle C at the point A. So we've got the point A. We just need to find the equation of the tangent. Now I think, again, a sketch is a good idea here. Just trying to see what's going on. So we'll see if my artwork gets us through here. That actually weren't too bad, to be honest. It's normally a lot worse. So what I've got then is my circle. My centre is 2 minus 1. So we could say that's, I don't know, there for example, right? That's my centre. So if we draw the circle in, say that's my circle. What we're looking for then is the tangent at the point 4 minus 5, which might be, say, there. Okay, that's my point A. So that's 4 minus 5. So we're looking for the tangent at this point. So this is going to be the line here. Okay, it's going to look something like that. Might look a bit neater, but just to get the idea across there. So how do we actually work out that equation of the tangent? Well, the easiest way is to work out the distance, sorry, the gradient here between my centre and my point A. And if we work out that gradient, the equation of the tangent then would simply be the negative reciprocal of that, the perpendicular gradient. So let's work out the gradient of, so what's our point? So it's A to the centre C here, so the gradient of AC. So the gradient of AC, well, that's simply going to be minus 5 minus 1, so minus 5 plus 1, divided by 4 minus 2, So 4 minus 2. So minus 5 plus 1 is minus 4. We divide that by 4 minus 2, which is 2. So minus 4 divided by 2 is minus 2. So that's the gradient for this point here to here. So that's a gradient of minus 2, which would make sense. It's a negative gradient. And obviously it should make sense that this is a positive gradient, because we're going up. So the perpendicular gradient then, so perpendicular gradient would just be minus 1 divided by this gradient here, minus 2. Or the other way you can do it is times that by minus 1 and then take the reciprocal. So the perpendicular gradient in this case, m, so that's to represent the perpendicular gradient, would be a half, so 1 over 2. Okay, so all I need to do now is use y minus y1 is equal to m lots of x minus x1. And we use that at the point A, okay, which we already know is 4 minus 5. So this is going to be y minus minus 5, so that would be plus 5, is equal to a half of x minus x1, so x minus 4. Now the first thing to note is the required form is ax plus by plus c, and a, b and c are integers. So we need to get rid of this half here. So to do that I'm going to times both sides by 2. So I get 2y plus 10 is equal to x minus 4. And I'm going to keep the x positive here, but it doesn't matter. You could take the x minus 4 onto this side. But if I subtract 2y and 10 off both sides here, I get x minus 2y, and then minus 4 minus 10, minus 14. And this is all equal to 0 then. And there we have it. So that's our equation of the tangent there to the circle C at the point A. So that brings us to the end of this video. I hope this has helped. If there's anything that's unclear, like always, just leave a comment down below. Cheers.